Hello everyone and welcome to this online presentation. My name is Merasa Alizadeh from the International Professional University of Technology in Osaka, Japan. It's my absolute pleasure and delight to be given the opportunity to represent JOLT, the Japan Association for Language Teaching, as a Best of Affiliates presenter. In this presentation, I'd like to talk about language learning with immersive technologies from a theoretical and practical perspective. But before that, let me tell you a little bit about myself. I moved to Japan about 8 years ago to pursue a PhD degree as a Japanese government-sponsored international student. After studying Japanese for the first 1 year and a half, I entered the Graduate School of Information Science and Technology at Osaka University, where I completed my doctoral studies with a focus on technology-enhanced language learning. Doing my research in an interdisciplinary environment was not very easy, but it certainly exposed me to cutting-edge technologies that I would otherwise not have learned about or thought of applying to language education so soon. After finishing my studies, I was offered a short-term research position at the Cybermedia Center, Osaka University, where I worked with a team of AI and EdTech researchers to conduct research on the use of AI and sensing technologies in order to improve in-person and online higher education. A year ago, I started a new position at a newly established university also located in Osaka, where I teach EFL classes to undergraduate students who are aiming for the IT and digital entertainment job market. Aside from teaching duties, I continue doing research on technology-enhanced language learning, particularly on immersive language learning. My area of research is also the topic of today's talk, that is immersive technologies in language learning. So let's see what these technologies are and how they can help us teach languages better. But before I dive into the topic, let me tell you that I'm a digital immigrant myself. If you're familiar with Prensky's idea, you may have heard of digital immigrants, meaning the older generation not brought up with technology, as opposed to digital natives, which refers to the younger generation born in the digital age. Unlike most others in my generation, I was born and raised in a very low resource environment, and learning English for me as a second language speaker happened without any of these fancy technologies I want to talk about today, nor did I have access to any of the common Web 2.0 tools that are now so mainstream. But having said that, when I was placed in an environment with proper access to technology, I embraced the idea of technology-enhanced language learning, and I have always used technology in one form or another, both as an educator and as a lifelong learner. Here is another point to keep in mind as you watch this presentation. In the interest of clarity and accessibility, this talk will cover the basics of immersive technologies in language learning. So apologies if this presentation may be too basic for you. With any kind of technology, it's really important to keep the purpose in mind and constantly evaluate it. What is the technology doing to the benefit of the learners? Is it just substituting paper and pencil with a screen and a word processor? Is it adding any extra layers of augmentation to existing materials and learning tasks? Or does it take one step further to transform the learning experience by modifying or redefining it to such a great extent that it would be impossible to achieve the same learning outcomes in the absence of technology? The questions I just posed are based on the SAMR model developed by Dr. Pentadoro, based on research into how the use of digital technology is transforming classroom-based teaching and learning. As educators, we do want to aim for transformative learning experiences and thus have a mission to integrate technology in such a way that it will hopefully modify or even better redefine the learning experience. Now, this introduction finally brings me to the core section of this talk on immersive technologies. We hear the terms AR, VR, MR, and XR perhaps more often these days with the increase in the number of such apps and tools, but we may not know very clearly what they mean in practice. I know that's too many acronyms for one slide, but don't worry, we'll get to these terms one by one. Think of reality as a continuum, with the real world on one side and a completely virtual simulated world at the other end. And in between these two extremes, we can think of different levels of the mix of the real and the digital. These different states of reality are also referred to as extended reality, or XR in short. Starting with augmented reality or AR, this technology allows us to overlay digital 2D or 3D objects onto the real world, so when we look at a scene through the lens of a camera, we can see the digital coexisting with the real. AR became really popular with the rise of the Pokemon Go mobile AR game in 2016, in which people would try to chase Pokemon tied to various locations in the real world. This fun game, especially when first launched, got players so engaged that you would go to a Pokemon spot and find swarms of people gathering in one place and doing what? Looking at their phones. Unfortunately, rare Pokemon finds would sometimes lead to accidents too. You may be thinking you have never really used AR, but in fact this technology exists everywhere, more than we could imagine. When you use a photo or video filter on Instagram, Snapchat, or Zoom, you're actually augmenting yourself. Some businesses have made use of AR, such as eyewear companies with apps that allow you to virtually try on different frames anywhere, anytime. Another example is placing real-sized furniture in your room before purchasing it, which is now made possible again through AR. Last but not least, Google Lens allows you to translate texts in other languages real time and overlay the translated version on the real signboards around. AR also has use cases in education in general and language learning in particular, and also vocational training. As the picture on the left shows, the solar system planets can be seen and examined from different angles by the students and the teacher in the classroom just using smartphones. In a similar way, AR can be used for training staff on how to use a new piece of equipment, what its parts are, and how it functions. Now let me explain how AR overlays work. There are two main types of AR, known as marker-based and markerless AR. What distinguishes the two is the existence or absence of what's called a marker. Think of an AR marker as something like a QR code, which once scanned shows a URL or, say, an email address. Alternatively, scanning a marker can show a 3D model or an image or perhaps a video overlaid onto the real environment, like what you see in the image on the left. Markerless AR, as the name suggests, works without a marker. Such AR applications scan the environment first to look for a flat space on which they can place a digital content. As you see on the top right, I'm scanning part of my living room with an app called Sketchfab. The app detects a flat space marked by those white dots, which may not be very easy to see in this picture, but once I tap the screen, it places an object I selected, in this case a virtual plant, on that spot. So this is how markerless AR works. Out of the educational AR apps out there, I have selected two to show you. The app on the left is called Orientation. The developer, my good friend and colleague Eric Hawkinson, has used this AR app to connect his university students with the local community through creating AR rallies around town. It is also being used at orientation sessions to get incoming cohorts of students familiar with campus and life in a small town named Fukuchiyama, located in northern Kyoto. The video on the right side is a demo of a coloring app for kids called Quiver Vision, which can make the colored creature come to life. You can imagine how exciting this can be to kids. Two examples of markerless AR can be seen here. The first one, the app on the left, is called Sketchfab. I already mentioned it when I was explaining how markerless AR works. Well, using this app and some design thinking, you can create immersive learning experiences. Another AR app, which was closed down in 2021, is an AR app by Google called Expeditions. This app started as a VR or virtual reality app, and then soon AR content was added to its repository. Similar to Sketchfab, it would allow you to place digital content onto the real world and examine animals, places, artworks, and so forth closely from different angles and at different sizes. These 3D models can be great in content learning, but also for language learning too, to stimulate conversation and to learn new vocabulary while being engaged. Mobile AR is growing exponentially with more advanced mobile devices in our pockets. The latest models of some smartphone cameras are equipped with a technology called LiDAR, which stands for light detection and ranging. In very simple words, such cameras send beams to the environment to scan it and to detect the objects around them, and also to calculate the distance and depth measurements. This is a huge game changer, as this technology makes 3D modeling possible and accessible for everyone, even without computer graphics skills. The good news is that even if you don't have one of these very recent smartphones with a LiDAR camera, there are apps that allow you to 3D scan objects by taking various shots from different angles and having the app to reconstruct a 3D model using those 2D shots. WiDAR, replace the L in LiDAR with a W, is one of those apps. The use of AR in learning and teaching is supported by theories such as constructivism, sociocultural theory, situated learning, inquiry-based learning, discovery learning, and connectivism. You can also refer to the sources listed here for more details regarding the theories and how they support the use of AR in education. Regarding its applications, though, AR can be used in content learning and content and language integrated learning as well. It can also be used in creating campus tours and scavenger hunts. Another interesting use case I have come across in Japan is the use of AR for library and self-access learning center guides. This is a good source of motivation for students to visit the library and self-access learning centers and use their resources. Despite the benefits, using AR in education has its own challenges. The first hurdle is that there are not as many AR authoring tools out there. By AR authoring tools, I'm referring to platforms that allow educators without knowledge of programming to create their own AR-powered learning experiences. There is also an issue of hardware dependence. AR apps are usually not compatible with old smartphones. And finally, as is the case with other types of new technologies, there is not yet enough teacher training available through institutions to get teachers up to date with these latest advancements. Next, I'd like to move on to another instance of immersive technologies, which we also hear a lot about these days, and that is virtual reality or VR. VR, as the definition from the literature shows, is an immersive computer-enabled technology that replicates an environment and allows a simulation of the user to be present and interact in that environment. One common feature of most VR environments is the representation of users as avatars. You can see my avatar here attending a virtual event of our special interest group within JOLT called Maver on a virtual platform called AltSpace VR. VR can be experienced on a PC or a mobile device, also known as web VR, or a head-mounted display, or HMD, also known as a VR headset or VR goggles, and finally, in a more complicated manner, in what is called a cave. CAVE is a recursive acronym that stands for Cave Automatic Virtual Environment. The name is actually a reference to the allegory of the cave in Plato's Republic, and you would need projectors in an enclosed environment to create that immersive effect. This is perhaps too complicated to set up for the classroom, but the first two types of VR seem more applicable to educational settings. What distinguishes web VR from HMD VR is the degree of immersion, that is, the extent to which the system is capable of shutting out the outside world. HMD VR is usually considered full immersion VR, whereas web VR would only create partial immersion. To show you in practice how web VR and HMD VR work, I have created two screencasts of myself in AltSpace VR. The first one is on a PC. As you can see, I can move in this virtual space with 6 degrees of freedom. To move, I'm using the arrow keys or the WASD keys to move forward, left, backward, and right. These are the same keys that we use when playing computer games. I also tried to interact with some of the items in the environment, such as fireworks and basketballs. Honestly, it's pretty hard to make a good shoot using the mouse. As you can see, I didn't do a good job at all. Now this screencast shows me in the same environment, this time on a Meta Quest 2 headset. I'm holding two controllers which appear as my virtual hands, and I can move around by pointing to a certain spot to land on or to teleport to, as well as use the thumbstick button on the controllers to move around. The same sort of interactions can be made with the objects in the environment, this time a lot more easily thanks to the controllers. As you can see, I'm trying to do more fireworks here before I move to the basketball area. And yes, I'm using controllers to move and then to grab objects like a basketball and to try to throw it using my hand motions while holding controllers. You can see me doing this in the bottom right corner. And yes, I aced my shoot this time. VR has various affordances for education in general and language education in particular, since it provides an immersive learning experience that can engage students and help them stay focused. The sense of presence, the feeling that you're actually in an environment, and sense of co-presence, that is, being with others in an environment, is actually much stronger in VR than it is on Zoom or other teleconferencing platforms. Cognitive embodiment is also said to be one of the advantages of VR integrated language learning, as well as increased engagement and motivation, and higher sense of empathy. Despite all these benefits, there's a lack of VR educational apps. I carried out a study with a small group of students and a colleague 2 years ago, in which we asked the students to take a self-directed learning approach and look for free VR apps that could be used for educational purposes. The students could not find many, but those that they did find could be roughly categorized into immersive documentaries, content-specific apps, social VR apps, and VR games. Another term that's really popular these days and sometimes used synonymously with VR is the concept of the metaverse. It refers to a future iteration of the internet that's made up of persistent, mutually shared 3D virtual spaces that are linked into a virtual universe. The term metaverse entered a tech lexicon from science fiction, and it was first coined by Neil Stephenson in his 1992 novel titled Snow Crash. The metaverse made it to the big screen with Ready Player One, a movie adaptation of a 2011 sci-fi novel with the same title. Large tech companies these days like Microsoft, Meta, and Apple are betting big on the metaverse. There's even talk of Metaversity, Metaverse University as the new generation of online universities and campuses. Related to the metaverse is the concept of digital twins, a virtual representation that serves as the real-time digital counterpart of a physical object or process. There have been attempts around the world to create digital twins, and this trend has been accelerated due to the COVID-19 pandemic. Existing examples of digital twins include the work done by the Natural History Museum in London, where they created a digital twin of some of their exhibits. Another example comes from Singapore and is led by the National Research Foundation Singapore, in which they created a digital twin of the entire state to help monitor traffic, environmental changes, climate change, and so forth. VR development does sound too complicated for educators. However, the open VR protocols allow general users to create their own social VR environments using platforms such as Mozilla Hubs. Mozilla Hubs makes it possible for users to create different virtual spaces for free. There's a limit to the number of users that's approximately set to 25 users for the system to run smoothly. However, more users can be present in the environment as the so-called spectators. Mozilla Hubs in similar platforms allow users to navigate in VR, add digital content such as PDF files, 3D models, digital whiteboards, scribbles, and so forth. Users are represented as avatars and they can communicate audio-visually as well as use the chat for text messages. Getting into groups can be done really easily in VR, just like the way we do it in a real in-person environment. All you need to do is to get close to other avatars to be heard by them, and as soon as you move away from them, they cannot hear you anymore. This is called spatial or proximity audio and is an important feature of VR environments that can be leveraged for learning and teaching. Editing an existing VR environment or creating your own environment from scratch is also possible using a related platform called Spoke, although it can be a little complicated. Next, I'd like to continue this presentation by introducing some educational VR projects I know from my colleagues. The first one is the use of VR in treating public speaking anxiety. My colleague Josh Bernardi has been pursuing this line of research for his doctoral dissertation, and he has used an app called Virtual Speech with learners to see its impact on their public speaking anxiety. Past research indeed also indicates some evidence regarding the positive impact of VR on reducing public speaking anxiety and foreign language anxiety. Moving on, another colleague of mine, Rob Figuera, working in both Japan and the Philippines, has used virtual tour-based learning, which can encourage and support discovery learning and inquiry-based learning. In addition, VR has been used by my colleague Eric Hawkinson for immersive storytelling. I was involved in some of the earlier iterations of this project, and I witnessed how WebVR supported the implementation of this idea during the pandemic when all classes suddenly were shifted online. Finally, I'd like to briefly explain about my own current project. I'm now investigating the impact of WebVR on student engagement and learning outcomes. This research has been designed as a quasi-experimental study in which I will compare the use of Zoom with WebVR in relation to learner engagement and learning outcomes. The specific area I'm focusing on is small talk, and I'm conducting this project with my Japan-based colleague Neil Cowie. We have just finished the first phase of the study and plan to present and publish on this ongoing project, so please stay tuned. This brings me to the challenges of VR in education. Researchers and practitioners have also expressed concerns over the challenges involved in using VR for learning and teaching. First of all, as I already mentioned, there are not that many educational VR apps out there, and there are even fewer free apps. HMD VR apps can also be more expensive than regular Web 2.0 apps. Just like with AR, device accessibility can be an issue whether you're using Web VR or HMD VR. Web VR requires PCs with a good spec and relatively good processing power to run smoothly. HMDs or VR headsets are also too expensive to buy individually without proper sources of funding. Finally, cyber sickness, especially in the use of HMD VR, can be a huge hurdle and can cause users to experience varying degrees of fatigue, eye strain, and also motion sickness. I would like to conclude my presentation with an awareness-raising remark regarding the ethical issues evolving around immersive technologies. As you can probably guess, the biggest ethical concern is that of user data collection. The data collected in immersive environments, especially with full immersion, is not only limited to personal information and location, but also extends to biometric data of hand movements and head motions. The more sensors these devices are equipped with, the more data it's possible for the manufacturers to collect, such as eye tracking data. The data collection can cause violations to user privacy if not handled properly and could potentially be used for targeted advertising. All these ads we see everywhere based on our search keywords and the like can be aggregated using data from immersive environments. There are some ethical issues for which there's no definite response yet, but as educators, it's important to be aware of them and try to protect our students' privacy as much as possible by using these technologies appropriately. This brings me to the end of this presentation. Thanks very much for watching. If you'd like to reach out to me, please contact me via email or find me on Twitter. I welcome any questions you may have.